excited to be here with you and in this welcoming community and awesome city of Austin. I came all the way from Paris, France, to talk about Pylint. So these days, Pylint doesn't sound really sexy, and I'm going to try to make it a little bit sexier and faster with pants. But first, a little bit about the company I work for. The company is called Doctrine. We do legal intelligence platform. So basically, we do pretty much everything that's related to laws in France and provide a lot of services around that. The main domain is legal, and we get data from all over the place and different kind of sources. Many institutions in France, they all format the data completely differently, so it's a big mess. And so this morning we were talking about the medical stuff and the data, how messy it is, how a big nightmare it can be. Well, legal system is pretty much the same. This is French content mainly, and this shouldn't be an issue, but I don't know. In France, I think we do not know simple is better than complex. And so this plus the fact that we have a lot of code per developer in that company, we end up generating code that's overly complex. And me included, I mean, we need something to control it and to make it more mutualized and generalizable. All right, so if I want to have data that's completely tested, that's correctly interpreted and correctly used by all the consumers, we've implemented a lot of tests, a lot of documentation. Pretty much everything is typed, so we enabled pretty much all the tools that we can find on the market. But still, sometimes when we do a review on a PR, I'm like, what I'm gonna do? Why is this code formatted like this? Why are we not using this pattern over this one? And we don't understand each other. We generate complex code, and it's become very hard to maintain and to review. So I wanted to introduce a bit more patterns in linting and customizable stuff. And we went with Pylint. So Pylint can be resumed in 4 things I've listed, I think. First is a static code analysis. So it reads the code, it doesn't run it. Unlike we can do while we were testing, we need to instantiate things and stuff. In that case, when linting, it's not needed. Pylint brings an internal engine that allows great flexibility, and I'm going to come back on that one because that's the key for us to generate all the linting capabilities that we added. It's not a formatter, so unlike black or isort or rough, it doesn't replace your code in place. It doesn't fix your code. It just tells you this is wrong, this is not the right pattern, you should use that, etc. And maybe a conclusion on Pylint, a quote that I found on the PyPI page for Pylint. Inference is the killer feature that keeps us using Pylint in our project, despite how painfully slow it is. So even Pylint is publishing that on their PyPI page. So I guess this is really slow. And when you start using Pylint or you've been using it maybe for a while, what you get these days is, all right, start using Rough instead, get rid of Pylint, this is too slow, this is too old, make everything under Rough. Well, we were talking about the internal capabilities of Pylint and some of the great features that we can use to generate custom stuff. And this is exactly why, well, I'm using Rough for pretty much everything, but for everything that's customizable, I kept Pylint. And I generated custom rules, custom linting rules in Pylint. So what are those, and why would I need those? Well, first, you may have some internal company rules, like things that should be applied to every code you generate. So like naming conventions, format conventions, or whatever internal convention you have in the company. We do have some, the naming conventions, for instance, because a lot of the data we're handling is tricky. I mean, in the legal system in France, most of the words, that's my native language, but most of the words I don't even understand it. They are new for me. So imagine like when you're generating code out of that, if you want to parse that, that's a nightmare. So we've got a lot of naming conventions and maybe some package conventions. Sometimes you want to just, I don't know, restrict the use of that function or this function in that place, or use it that way, but done that way. And at some point, you want to avoid things to be published to productions. So what you can do to do that is to fail the CI. And if you fail tests, if you fail typing, if you fail linting, then you fail the CI. And when you're reviewing a lot of PRs every day, a lot of code, maybe sometimes you have some things that you repeat every day, sometimes to the same people. And it's not that we are not understanding what we should do. It's just that there's so much we need to carry in each PR, and so much that we can, that we should tell all the developers to do at each time. Well, at some point you want to be able to automate all of that, because that's less burden for the reviewer and probably less stress for the developer as well. And what you get at some point is that you get faster code reviews. I mean, if the PR already passed a very strict CI, then the review got a lot easier. So custom rules based in Pylint, they can be based on 3 kinds of checkers. So basically, the finer you get in the interpretation, the slower you get in the process. So keep in mind that I already said that Pylint is slow, and now I'm just saying that I'm going to add some stuff that make Pylint even slower. Because, you know, from experience, if you want to publish some rules, some company rules or linting and stuff that you cannot do with the base configuration from Pylint, well, you're going to end up building some really complex stuff with AST or, I don't know, with really fine interpretation. So I'm going to show you a quick example. And I thought this example was really done at some point, and I just wanted to illustrate how I could forbid the usage of UTC now from that time in our code. So I'm going to use the token checker from Pylint. implement whatever I need from the base checker and the iToken checker interface. And this sounds dumb at some point, but when I flew in here from Paris and I had to go to London, and there was some delay on the flight from Paris to London, and arrived in London, since they are not in the UE anymore, we had to go through customs again. And we got delayed like a lot, and arrived at security. On my boarding pass, I had a flight for 11:30, and the security guy was like, okay, so you need to speed up, just cut the line and go directly to that checkpoint. And the people right behind me, they were like, my flight is at 12:30. And so they had to go in the line because there was 1 extra hour after. But we were all taking the same flight. It's just the different companies that generated the boarding passes, they got messed up with the time zones, because daylight savings was, the change was last weekend, and some of us got the, I don't know how it could happen in 2023, but still, it happens. All right, so second step, how you identify the error in the checker. And this is exactly what you need when you want to ignore an error with Pylint or Flake 8 or any related stuff. Okay, and the magic of the checker. So basically, I'm gonna have a list of tokens. So those tokens, the token info type is the built-in type from Python. So you could check it out right away. It's really simple to use. And then I got the magic. So if I'm calling something that's UTC now, just raise a message with exactly the file, the line start, and the column. That's that easy. All right, so that's the event that we're sending to Pylint. So what happens exactly when I run Pylint? So I'm going to run the common Pylint something being like my whole repository, just a folder, maybe just a module. It takes, well, whatever custom checker I made, so the first-party plugins. It also loads the potential third-party plugins that I added, and then it loads the code that I want to run the linter against, and it runs the linter. So on the left side, you have the code that you're maintaining yourself. They're not supposed to be in the same runtime, meaning they're not supposed to import each other. So there's a high chance they are not located in the same repository. They could be at some point, and I'm going to illustrate that. But if they're not in the same repository, that means that if you made a mistake in your checkers, or you forgot something, you want to add a new one, or whatever, you have to go through new code, new release, new potential CI, etc., and then reload, replay again, and back and forth, because you might have forgot something again. And that's exactly where Pants will come into play. And I can even illustrate it with the t-shirt. All right. Yeah, that's gonna look sexier after. Okay, all right. So, what does Pants have to bring? From the purely user perspective of Pants, I'm gonna show you what I will gain and what it does to my CI and my monorepo. All right, so first, Pants is a build system. It doesn't do all the magic, but pretty much. It manages your repository and brings a lot of CI tools with it. So Pylint comes with it, for instance. And the code that's going through CI will be magically, for now, split into subgroups, and the CI can be optimized with these subgroups of files. As a build system, it can manage several projects, and several projects into one single repository. And that's a cool thing, because as I was saying before, I had my 2 projects located in 2 separate repositories, and I had to republish and do all the things that I need to in order to be able to play again all the checkers. So now it's all located in the same place, so I can skip all that all those painful steps. And in the end, it's a mono repository. So you might want to add other projects. And since we're talking about generalization, mutualization, well, that's perfect, because I'm gonna mutualize a lot of rules and a lot of conventions into that single mono repository that carries several projects. And going forward with that, you could add all your repository into this one and apply exactly all those rules. It also comes with a lot of optimizations under the hood. It has a tremendous cache. It can build executables out of your code. Whatever script you made, it can generate an executable. And it has a very acute knowledge of your structure, of your repository structure. And I think it knows your code better than you do. So back to the illustration before, now it could look like this. So I have Pants in the middle that manages everything. It will load whatever is related to Pylint, so all the first-party plugins, the third-party ones, the configuration, etc. It will generate a runner for me. And all of this is like one single command. I don't need to know exactly what's under the hood, but I know that's one single command, and that's easy to do. And like I was saying, it splits my code that I want to lint into smaller groups and will run in parallel this runner that got generated against all these subgroups. And I was mentioning before, it comes with tremendous cache, and now my setup can look like this. So basically, the runner will be generated only once, because all of the spaces above Pants, like Pylint, the checkers and everything, they got generated once. They were used to generate a runner. The runner is now cached, and I don't need to worry about rebuilding it, because I'm not planning on changing right now all the custom checkers. So I will not generate any. I will not generate any changes that will trigger the cache. And it's the same for the code I want to lint. I mean, there's only one group of files that I'm changing, not all the stack. So I want to focus on those files only and apply the linter only on those files. And that's exactly what Pants can do. So now, instead of running over all the stack, we get to target exactly what has been changed. In fact, Pants stores the results of the previous iterations when it got changed. So at some point the cache got set, and now we can still get the results out of this cache. And so I've set up, like back I think 4 months ago, I've set up a repo with all of these pieces. We are migrating a lot of code into that, and the results were extremely satisfying. So on that repo, applying Pylint takes about 35-40 seconds. And now I got a small illustration of the time it takes. So I just wrapped everything I need in the make lint command, and that's it. It takes about maybe it's faster than, yeah, it's about 5 seconds. So it's a lot better than the 35 to 40 seconds I had before with just Pylint. So if I want to sum up what Pants brings, and with this setup with Pylint, well, I got my custom checkers. That was at some point I thought it was not the best option because it makes Pylint even slower. But still, we got them in the CI, which makes the review, like I was saying, faster because I know that everything that I encoded into checkers is automatically checked. We do spend less time, and we do avoid all the back and forth that we had with developers before. And we get, if I quote a talk from yesterday, now we got something like a democracy between the reviewers, because we have more reviewers, but fewer specialists, because all the specialized rules, they all got encoded into checkers. So there's no need for a human to remember and apply this rule. It's automatic. The linting time, thanks to Pants, is almost constant, and I'm going to show you an illustration. And since the linter is faster, well, we get faster feedback directly from either the CI or feedback you can have when running in local on your machine. So I was saying I've set up this on a monorepository like 4 months ago. And so you can see in blue the evolution of lines count in the repo. So it's still, I guess, low. We reached 25K approximately. Well, in these 4 months, we tripled the line count, but we got a constant linting time. You can see a few peaks because, as I was saying, the cache relies on the checkers, whatever they are, from first party or third party, the configuration and etc. But I had to add some other custom checkers through time, and you can see the peaks where the cache is not valid anymore, and you get to regenerate it. I guess we have an average of 8 seconds for the linting, which is a lot faster than the 40 seconds I had before. So I'm really happy with that setting, and we'll probably we will probably add a lot of code in that repository. I expect to grow at least 50 to 100 times this repository, and I hope the linting time is going to stay under, let's say, 20 seconds. I don't see how it should grow at some point, because it is fairly constant, and with As it checks only the added code through the PR, it shouldn't go any higher than that. All right, that's the end for me. I hope you liked it, and if you have any questions, feel free to reach out. And before I let you have some questions, I'd like to give a big thank to the Pants community. You can find 2 maintainers over there. I got a lot of help from them for setting all of that, and the great results, they are also from the community. Any questions? Yes? So I said there's like 10,000 lines of code. Why did you want a model? Because this is just the beginning. So I'm expected to merge 5 to 6 other repositories, and we're supposed to reach at least 200,000 to 300,000 lines. At least. I mean, at some point, the goal of that monorepo is also to mutualize things. So we should be ending somewhere lower than the sum of all these repositories. All right. Thank you very much to everybody.